My name is Smriti Chaudhury, and today I'll be going over the 2025 Level 7 and 8 Math Kangaroo papers. Let's get started. Lisa has 4 wooden digits. She can use them to form the number 2025. Which of the following numbers is the largest she can form with these digits? So in order to do that, we'd rearrange the digits greatest to least, which would be 5, 2, 2, 0, and we get our largest number, which happens to be C. So our answer is C. Number 2. Isabel rotates the hexagonal sheet of paper as shown. Each rotation turns the hexagon through the same angle in the same direction. The figure shows the result of one rotation. Which of these numbers of rotations would leave the sheet looking as it did in the start? So we're trying to figure out how many times we need to turn this paper to get it to look like this again. Since this is a hexagon, it's got 6 sides, 6 turns would make it look like this. But 6 is not an option, so we'll have to go for a multiple of 6. And since we have 12, that's our answer. So E. Number 3. Sandra rolls 3 dice and gets a total of 8. Each of the 3 dice shows a different number of dots. Which number of dots could Sandra not have rolled on any of her dice? So she's rolling 3 dice and their sum is 8, but we can't have any repeats. So we try our greatest number, which is 6 for a dice, and that means the other 2 have to be 1 because there's no 0 in dice. And since there's repeating, we can't have 2 1s. 6 is the number we can't roll. So our answer is E. Number 4. The regular hexagon shown is divided into many triangles of equal area. What fraction of the hexagon is shaded? So in order to find this, we're going to count the number of shaded parts and divide it by the number of total parts there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 shaded parts. And then for counting the number of parts, let's take the easy route. We have in 1/6, there are 1, 2, 3, 4, 5, 6 parts. 6 times 6, 36. So 12 over 36, which is also 1/3, is the fraction of the hexagon that's shaded. So B is our answer. Number 5. How many sets of 12 minutes are there in 12 hours? So 1 hour has 60 minutes, so 60 divided by 12 is 5. We've got 5 sets of 12 minutes in an hour. And then we want for 12 hours, so we're going to multiply that by 12, and we get 60. So there are 60 sets in 12 hours, and A is our answer. Number 6. Daniel is 5 years old. His brother Dominic is 6 years older. What will the sum of their ages be in 7 years? So we know that Daniel is 5, and his brother is 6 years older, so 6 plus 5, 11. So we want to know the sum of their ages in 7 years. So since Daniel's 5, he would be 12. And since Dominic is 11, he would be 18. Add that together and we got 30. So our answer is E. Number 7. Omar wants to write the 4 digits 2, 0, 2, and 5 in the 4 boxes the calculation showed. What is the smallest result that Omar could get? So one thing is that this is addition, so we've got one part and another part. And it doesn't matter which numbers go in these 2 parts because either way, addition is commutative, it equals the same thing. So we put our 2 lowest values in the front, so we'll take 2 and 0, and their 2 greatest values, 2 and 5, in our second boxes because that gives us the lowest value. So 2 minus 2, 0, plus 0 minus 5, negative 5, which we end up with negative 5. So our answer is C. Number 8. There are 10 more truth tellers than liars in a room. Truth tellers always tell the truth and liars always lie. Everyone in the room was asked, "Are you a truth teller?" And everyone gave an answer. A total of 20 people answered yes. How many liars are in the room? So one thing, we know that there are 20 people in total because truth tellers will say yes and liars will lie. So they'd say yes, so everyone says yes. So let's write this down in an equation. So we'll call truth tellers T and liars L. So we know that there are 10 more truth tellers than liars, so that T equals L plus 10. That's an L, not a 1. And we know that a total of 20 people answered, so T plus L is 20. And now we'll just plug in this. So we've got L plus 10 equals 20. And I'm pretty sure you can solve this out and figure that L equals 5. Because 20 minus 10, 10 divided by 2, 5. So there are 5 liars, and our answer is B. Number 9. 5 circles, each with an area of 8 centimeters squared, overlap to form the figure shown. The area of each section where 2 circles overlap is 1 centimeter squared. What is the total area covered by the figure? So we've got 5 circles, and each of the circles' area is 8 centimeters, so let's do 5 times 8 is 40. But then, the parts where they overlap, we counted twice, so we gotta subtract that. We have 1, 2, 3, 4 overlaps, and each overlap is 1 centimeter squared in area. So we do 40 minus 4 times 1, which is 4. So we'd get 36. So the area of this figure is 36 centimeters squared, or B. And that is our answer. Number 10. The real combination of the bicycle locks shown in the picture is 0, 0, 0, 0. However, when someone looks at it from the side, they see 8, 8, 8, 8. When Paul looks at the combination of his friend's lock from the side, he sees 2, 8, 1, 5. What is the real combination of his friend's lock? So taking a look over here at our lock, we've got our 0s here, our 8s here, and one trick, if we were to look at the 9s, we could just add 1. And for the 0s, this also works. We can just add 2 to get to our actual number. And instead of 8 plus 2 is 10, but we don't have any 10, so we reset at 0. So let's try that trick on this. So we add 2 to every digit, and we end up with 4, and then 8 plus 2 is 10, but we're going to reset. So 0, and then 3, 7. So our answer is 4037, which is A. Number 11. Matthew the mouse wants to get to a piece of cheese. He can only move horizontally or vertically between any 2 cells in the direction shown by the arrows. How many different routes can Matthew take to reach a piece of cheese? So the strategy we would solve this with is by multiplying the number of ways that Matthew can start and the number of ways Matthew can end, because Matthew has to go through the middle piece. So Matthew can start by either going this way or this way. So that is 2 ways. Then Matthew can end this by entering this way, or that way, or this way, or that way. So 4 ways. So 2 times 4 is 8. Matthew, either way, has to go through this block. So 8 different routes that Matthew can take to reach his piece of cheese, which is C. Number 12. There are 5 hurdles in a 60-meter hurdle race. The first hurdle is after 12 meters. The gap between any 2 consecutive hurdles is 8 meters. How far is the last hurdle from the finish? So we can solve this by drawing a little model. So we've got our start to our finish, and we know that this is 12 meters. And then we've got our hurdles in between. That is 8. And then we've got this unknown distance. So 8 times 4 is 32. And then we've got 12 plus 32, that is 44. And so we know that our distance is 60. So 60 minus 44 is 16. So our unknown distance is 16 meters, which is A. Number 13. Edgar wants to write a number in each circle in the diagram. He wants each number to be equal to the sum of the numbers in the 2 adjacent circles. He's already written 2 numbers, as shown. What numbers should he write in the gray circle? So the value in this circle is going to be the sum of 1 and 2, which is 3. And then 1 is the sum of 3 and something else, which would be negative 2. And 2 is the sum of 3 and negative 1. So this circle would be negative 3, because negative 2 minus 1. So our answer is D. Number 14. Luis places 3 rectangular pictures in the way shown. What is the value of x? So in order to solve for x, the first thing we need to do is acknowledge that this is a quadrilateral, even if it's a rather weirdly shaped one. And let's also acknowledge the right angles from the rectangles. So this is a right angle, this is a right angle, and this is a right angle. So since this is 90 degrees and this whole part would add up to 180, that means that this angle right here is 90 minus x. That angle over there is 90 minus x. Sorry about that. And this angle over here is 270 from this perspective. And over here we have 62 degrees and 90 degrees, making this 28 degrees. So now that we know that this is a quadrilateral and we have somewhat of an idea of the angle measures inside, we can create an equation. So 28 plus 42 plus 90 minus x plus 270 equals 360, because it's a quadrilateral. And 90 plus 270 is 360, so we can cancel that part out with this. So now 28 plus 42 is 70. We've got 70 minus x equals 0, which means that x equals 70, which our answer is B. Number 15. Warren is on a treadmill in the gym. He keeps looking at 2 stopwatches. The first shows the time elapsed since he started the session, and the second, the time remaining until the end of the session. At some point, the 2 stopwatches show the same reading. What do they show at that point? So this stopwatch measures since the time he started running, and this one measures how much time is left. So if we were to add these two together and divide by 2, so we take the average, we'd find out when they both show the same thing. So if we were to add these two numbers together, we get 3630. And since we're trying to take the average, we would divide it by 2, which is equal to 1815. So when they both show the same thing, they will show 1815, which is D. Number 16. Julia wants to fill in each box with a different prime number less than 20, so that the value of A is an integer. What is the maximum value of A? So these are the prime numbers that are less than 20, and so in order to get the greatest possible value for A, while still being a integer, we want to arrange this in such a way that we get the lowest possible denominator. And so in order to solve for that, we're going to rewrite this as the sum of these numbers minus whatever number we choose for the denominator divided by it. So the sum of all these prime numbers is 77, then minus x divided by x. So now we want A to be the greatest, and so we're going to start with the least possible denominator values. So let's try 2. That would be 75 over 2. But that's not an integer, so that doesn't work. Next, 3 would be 74 over 3. But that's also not an integer, so that doesn't work. And the next 5, we got 72 over 5, which doesn't work. Followed by 7, which would be 70 over 7, which does work. That's an integer. So A equals 10, which is C. So our answer is C. Number 17. Mark wants to fill in the cells on the diagram shown so that each cell contains either a cross or a circle. He also wants to ensure there is no line of 4 consecutive identical symbols in any column, row, or diagonal. When he has completed the diagram, what will the column colored gray contain? So in order to solve this, we'll work through it step by step. So since we know that we can't have 4 of any consecutive shape, we'll go off of that. Here we have 3 X's, and so that has to be an O. Here we have 3 O's, that must be an X. 3 O's, an X. 3 X's, an O. 3 O's, X. 3 O's, X. 3 X's, O. 3 O's, X. 3 X's, O. 3 X's, O. 3 O's, X. 3 X's, O. 3 O's, X. 3 O's, X. 3 X's, O. And 3 X's, O. So now over here in this column, that's what we were solving for. Here we have 2 circles and 4 X's, which would mean our answer is B. Number 18. In the rectangle ABCD, the points E and F are marked on side DC as shown, so that angle EBA equals angle DFA, which is equal to 45 degrees, and AB plus EF equals 20 centimeters. What is the length of BC? So going off of that, we know that these parts are 45-degree angles, which would mean that this is also a 45-degree angle, and this is also a 45-degree angle. And since these are right angles, because this is a rectangle, it means that these are isosceles triangles, so the sides are the same. So EC is the same as BC. And this is important because another way we can look at AB plus EF is the sides of these triangles. We have DF plus EC. EF is the overlapping part. So we could write that as 2DF is equal to 20 centimeters, which means that DF, which is also equal to EC, which is also equal to BC, is 10 centimeters. So our answer for BC is 10 centimeters, which is D. So the answer is D. Number 19. Sonia has 2 bowls of numbered balls. Bowl X contains 7 balls numbered 1, 2, 6, 7, 10, 11, and 12. Bowl Y contains 5 balls numbered 3, 4, 5, 8, and 9. Which ball should Sonia transfer from bowl X to bowl Y to increase the average number of balls in each bowl? So first, before we get there, let's calculate the averages of each bowl. So the sum of all the numbers in bowl X is 49, and since there's 7 numbers, our average is 7. And the sum of the numbers in bowl Y is 29. With 5 numbers, that makes it 5.8. Now, we want a number that is less than 7 so that bowl X's average increases, but greater than 5.8 so that bowl Y's average also increases. So we want our number to be like this. And the only number that's in bowl X that fits that category is 6. So our answer is 6, which is A. So our answer is A. Number 20. Peter drew a quarter circle with center at each corner of a flag with dimensions 12 centimeters by 9 centimeters and colored the region formed as shown. What is the length indicated by the question mark? So first, let's label the parts on this diagram. So let's call this A, which means this is also A, B, and B, C, C, D, and D. And the part we're solving for is x. Now let's write down this as equations and then solve for x through those equations. So a plus b equals 9, b plus c equals 12, c plus d equals 9, and a plus x plus d equals 12. Now we want to isolate x, so let's make the equations a little more simple. So let's add these two equations and these two equations. So this would become a plus b plus c plus d equals 18. And this becomes a plus b plus c plus d plus x equals 24. So the only difference between these is x, but this is 6 more, which means x must equal 6. So our answer is 6, which is B. So our answer is B.
Number 21. In the 6-digit integer papaya, different letters stand for different digits, and the same letter always represents the same digit. Also, y equals p plus p equals a plus a plus a. What is the value of p times a times p times a times y times a?
So another thing, we could rewrite this as y equals 2p, which is also equal to 3a. And something important to remember is that these are all single digits, which means the only value for y is 6. And if y is 6, then p must be 3, and a must be 2. So then, when we calculate papaya, we get 3 times 2 times 3 times 2 times 6 times 2. And if we multiply that out, we end up with 432 as our answer, which is A.
Number 22. During 2 sessions of soccer training, Paul shoots a total of 17 times at a target. He hits 60% of the shots he shoots in the first session. He hits 75% of the shots he shoots in the second session. How many times did he hit the target in the second session?
So let's call the number of shots taken in the first session X and the number of shots taken in the second session Y. So that would mean that of X number of shots he took in the first session, he made 3/5 X shots. In the same way, in the second session, he made 3/4 Y shots. So the total number of shots that he took would be X plus Y, which is 17. And one thing that we know is that 3/5 X has to be an integer, which means that X has to be divisible by 5. And same thing for Y. Y has to be divisible by 4. So let's look at the options for X. X can be 5, 10, 15, but not 20 because it's still got to be less than 17. Now, if X were 5, then Y would be 12. If X were 10, Y would be 7. And if X were 15, Y would be 2. But of all these options, only 12 is divisible by 4, so Y must be 12. Now we're trying to figure out the number of shots he made in his second session. So we want to know what 3/4 Y is, which is 3/4 of 12 and equal to 9. So our answer is D.
Number 23. Anurag leaves for school at 8 a.m. His school is 1 kilometer away. When he walks, his speed is 4 kilometers per hour. When he bikes, his speed is 15 kilometers per hour. He is 5 minutes early when he walks. How many minutes early is he when he bikes?
So it takes him, since he walks at 4 kilometers per hour and he's traveling 1 kilometer, that would take him 15 minutes. Now, if he were to bike, 1 kilometer would take him only 4 minutes. Now, since he leaves for school at 8 and arrives 5 minutes early, that means he would arrive at 8:15 because 8 plus 15 minutes would equal 8:15. And if that's 5 minutes early, his school must start at 8:20. Now, if he were to bike starting at 8, that would mean that he arrives at 8:04, making him 16 minutes early. So our answer would be 16, which is E.
Number 24. Ria draws 4 squares side by side as shown. What is the area of the shaded quadrilateral?
So we can solve for the shaded part by first finding the area of the giant figure and subtracting the triangles away from it. So here we know, let's find the sides. So we know this is 3, 4, and 2. So that means that this side is 9. And since we know that these are squares, we can use that to our advantage. Here, this is a 3 and a 4, so this part must be 7. And here, this is a 4 and 2, so this must be a 6. So in total, this side is 13. So the area of this full figure is 9 times 13, which is 117. Now, let's find the area of this triangle. That would be this over here would be 7 minus 2, so that's 5. And this is 9, so we have 9 times 5 over 2, which is 45 over 2, which is 22.5. Now this triangle over here, we know this is 4. Oh, 4 plus 2, so that's actually 6. And then this is 2 plus 6, so 8. So we have 6 times 8 over 2, which is 24. And then this, we know this is 6 minus 3, so 3 and 3. So 3 times 3 over 2, which is 4.5. And if we were to add all of these up, we would get 51. So the area of the shaded figure is 117 minus 51, which is equal to 66, and means that our answer is C.
Number 25. The letters P, Q, R, S, and T represent 5 consecutive positive integers, though not necessarily in that order. The sum of P and Q is 69, and the sum of S and T is 72. What is the value of R?
Let's look at some possibilities for P and Q. So 69 divided by 2 is 34.5. So P and Q could be 34 and 35, and it could also be 33 and 36. But not any other pair, because the most difference they could have is 4, since they're 5 consecutive integers. Moving on to T and S, 72 over 2 is 36. Now, since they're all different integers, we can't use 36. So S and T could be 35 and 37, or 34 and 38. Now, looking at this, both possibilities for S and T involve numbers that are in this set, which means we cannot use this set for P and Q. So P and Q is 33 and 36. Now for S and T, that means we cannot use this set, 34, 38, because the greatest difference you can have is 4 between the integers, but 38 and 33 have a difference of 5. So we know now that S and T are 35 and 37. So our numbers are, from least to greatest, 33, 35, 36, and 37. So the number we're missing is 34, which means R is 34, and our answer is C.
Number 26. When the height of a cuboid is reduced by 3 centimeters, its surface area is reduced by 60 centimeters squared. The resulting shape is a cube. What is the volume of the original cuboid in centimeters cubed?
Let's start off with the fact that the surface area reduced by 60 centimeters squared. So that means that this whole area, plus the part behind as well, is 60 centimeters squared. So that means that 3 times the perimeter of the square is 60. So 60 divided by 3 is 20, so our perimeter is 20. Now, since this is a cube, all sides are equal, so if we do 20 divided by 4, which is 5, we've got our edges. So this is a 5, 5, and 5. And now we want to find the volume of the original cuboid. So this side would have been 8, and this is still 5 and 5, so 25 for a base. So then the volume would have been 8 times 25, which is 200 centimeters cubed. So our answer would have been D. Is still D.
Number 27. In the quadrilateral ABCD, the points N and K are marked on sides BC and AD respectively, so that BN equals 2NC and AK equals KD. The area of triangle CKD is 2, and the area of triangle ABN is 6. What is the area of quadrilateral ABCD?
To do that, let's break down this figure even more. So we can draw a line over here, and the reason we would do that is because since these two lengths are equal, and they share the same point as a vertex, their areas are also the same. So this is also a 2. Now over here, they are in proportion with this side being twice as large as this side. So they share the same point as well. So this area would be twice as large as this area, meaning that the area of this is 3. So the area of the total figure is 6 plus 3, which is 9, plus 2 plus 2, so 13. Which means our answer is A.
Number 28. Some birds, including ha, long, na, and trang, are perched on 4 parallel wires. There are 10 birds perched above ha. There are 25 birds perched above long. There are 5 birds perched below na. There are 2 birds perched below trang. The number of birds perched above trang is a multiple of the number of birds perched below her. How many birds in total are perched on the 4 wires?
So let's put that down on a picture. We know that long has 25 birds above them, which means that long is likely on the bottom wire. We also know that trang has 2 birds below them, which means that trang is likely on the second to last wire. So that means that long has a bird next to them. We also know that na has 5 birds below them, which means that trang would have 2 more birds next to them. We know that ha has 10 birds above them, which means that there's likely none of the named birds on the top wire. We also know that trang has the number of birds above her as a multiple of the number of birds below her, which is 2. So since we have 10 birds here and 12 birds here to fulfill the 25 number, that's 22 birds, which is a multiple of 2. And since this scenario fits all criteria, this must be the number of birds, which is 25 plus long and another bird, so 27 birds. So our answer is 27, which is A.
Number 29. The second figure below shows a net of an octahedron. Each face of the octahedron is divided into 3 parts. The octahedron is colored with 3 colors, black, dark gray, and light gray, in such a way that the parts that come out of the same vertex or out of an opposite vertex are the same color. Which color could the part marked with the dot be colored?
So B is black, L is light gray, and D is dark gray. And since this is a vertex, this would also be black, and so would this, and so would this. And since this is also a vertex when folded up, this is light gray, which means this can only be dark gray. And now when we fold this up, this vertex would be the same as this vertex. So this is also dark gray, which means this is light, light, that one's dark gray, dark gray. This is black, also black. So are these. That would be light gray, which is also light gray, and dark gray. These are all dark gray. And that, which is the spot, would have to be light gray, which means that our answer is light gray, which is C.
Number 30. Adira keeps golden, red, black, pink, and white pearls in 5 small boxes. Each box contains pearls of only one color. The boxes are labeled as shown, and all the labels are true. Adira's friend Lily wants to know which box contains the golden pearls. She may open exactly one of the 5 boxes to look inside. Which box must Lily open to be certain which of the boxes contains the golden pearl?
Okay, so let's look at the options. First, take box A. Now, if it is golden, then great, you found it. But if it's red, all that tells you is that it could be C or D. So it's not box A because you don't know for sure. Moving on to box B. If box B is pink, then C is black, which means that A or D could be gold. So it's not box B either. Moving on to box C, we have, if box C is black, that means that that's pink, which means that that's white, but that doesn't really tell anything about box A or D. So again, it's not box C. Now, box D has a lot of options, so let's come back to that. Box E, if it's pink, well then this is black, which means this is gold. So yay. But if this is white, that doesn't really tell us anything, so not box E. Moving back to box D. If it's red, it's got quite a few options. So if it's red, well then this is golden, so we've got box A. Now if it's white, let's see. That means this is pink, which means this is black, which means this is golden, so box C. Now, if this is pink, that means that this is white, and that also means that this is black, and if this is black, this is golden. So it's again box C. And the one constraint is that it's not black, so we can't exactly try black. And if it is golden, then you found it. So box D tells you which box it is in. So our answer is D, not black. Thank you for watching, and good luck with Math Kangaroo. Bye!
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website. So bye!